Welcome, friends, to this another session of the Kubernetes Fundamentals series. My name is Rodrigo, and we are about to see the state persistence topic. Before we do that, let's do a quick recap of the previous session. You might remember that we talked about multi-container pods, right? That was our previous topic. And this is important because if you want to run multiple containers on the same pod, you can do that. And there are some use cases for doing that, such as implementing design patterns. For example, the Sidecar pattern or the ambassador pattern. And there are other use cases, for example, if you want to execute init containers. And I mentioned the analogy of the autosec.bat file that we had before, right, in MS-DOS. So we talked about init containers and we talked about sidecar containers. I mentioned Dapper as a framework that uses the sidecar design pattern. Dapper is this component that you download and you run Dapper as a sidecar container alongside your application, okay? And I actually showed you the code of how we can create those kind of manifests for sidecar containers. We talked about adapter containers and ambassador containers as well. And that's that. Today, we're going to talk about the state persistence because containers are ephemeral. You know, containers can be created and destroyed all the time. Actually, that's what happens in a Kubernetes cluster. Your pods are not meant to be running all the time. Of course, some of them could be running all the time. However, some things could happen with your pods. That's why we need some kind of persistent storage for, of course, storing the data that is related to that particular application, right? Again, each container has a temporary and isolated file system, but it actually, if you use it for writing data, let's say that you want to write data in this particular folder, then if the pod is destroyed, the data will be lost, right? So because that's the nature of containers. Those are ephemeral by nature. Containers start with a clean slate each time, and of course a new file system, right? So if you think about your previous pod instance, the previous container instance will be lost. You know, the data related to that instance will be lost because containers start with a clean slate each time, and they will lose the data if that's stored in the containers file system. So, I mean, this is the nature of containers. This is nothing new. I mentioned this, I think, in the first session about Kubernetes, because that's how Kubernetes and containers work, okay? So one way to address this is by using volumes, okay? This is one way to fix the nature of containers being ephemeral. So volumes is like mapping from your container to one part of the operating system, one part of the file system, actually. And there are different types of volumes that we can create in Kubernetes. I'm going to show you empty there, which is an empty folder that we can use to store data meant to be shared between different containers in the same pod. And actually, there are other types of volumes that we can use. I'm going to show you empty there. And then I'm going to show you persistent volumes and persistent volume claims, okay? However, volumes are a data storage abstraction. That's the basic definition of a volume in the Kubernetes topic. So this abstraction, of course, it's abstracting away the storage that you're using. Maybe you're using, I don't know, maybe a local disk, or maybe you're using, I don't know, a network drive, or maybe you're using cloud storage that comes from your cloud provider. Say that you're using Kubernetes in the cloud, then the cloud provider provides some ways to use those abstractions in your Kubernetes cluster, okay? So there are different types of volumes, and actually we can use multiple volume types within a single Kubernetes cluster or pod. This is common because you can, maybe you want some pods or applications to use this particular storage, and you want these other kind of pods or applications to use this other storage, right? So you're not constrained into a single storage type. That's what I mean. And they are created when the pod is created and deleted when the pod is terminated. This is the nature of volumes. You create a volume, and those volumes will be created when the pod is created and deleted when the pod is terminated, okay? So let's do the first example, that is this empty there volume example, okay? So that's one of the different types that we have for volumes, okay? Empty there is just an empty folder that you can specify so different containers can communicate between each other, or they can write data and read data from this shared place, okay? This shared storage. So for instance, as you can see here, I'm just defining a regular pod, right? API version, kind, metadata. And in the spec section, we're going to find the volumes field. Here in the volumes field, we can create this particular volume that we want to use for this pod, okay? So for instance, in this particular example, I'm creating the my volume, okay? That's the name. It could be the name that you want. Of course, it has to comply with the naming standards of Kubernetes. And I'm using the empty there type. That's why I'm using this empty there field here inside the volumes array, okay? So that's where you can specify other types of volumes if you want. In this case, I'm just defining a single volume, which is of type empty there. And then this is the first part, okay? You specify the volume, and then inside the containers element, you can use the volume mounts field to map the volume to your container instance, okay? So in this case, in this particular case, I'm using the my volume, okay? And I'm mounting that inside the data folder inside this particular container. In other words, if I navigate to the container instance, and I will see the data folder, okay? I will see that particular folder that I defined in this manifest, okay? So this is a pretty straightforward way of using volumes for our pods. And this comes in handy when you want to use multi-container pods. And actually, I'm going to revisit the Sidecar design pattern in this particular session, because I'm going to do that in code, okay? So this is great. Let's do the following. So I don't know if I have my Minikube instance already in place. Minikube status. Okay, so Minikube start, driver, Hyper-V. Remember this? So I'm about to deploy a Kubernetes cluster by using the Hyper-V driver inside this machine and blah, blah, blah. This is something that I've been doing since session 1, okay? Actually, I forgot to do this beforehand, so that's why I'm executing the Minikube start command now. but actually it's quite fast. So eventually I'm going to get this Minikube cluster in a few seconds, okay? So then I'm going to specify a new pod, and I'm going to specify the volume in this manifest that I'm going to create. And then I will use the volume mounts element inside the containers field so I can map my container to the volume. Okay? So let's wait for this. Booting up control plane, blah, blah, blah. It's almost finished. Yes. So we can run kubectl get nodes to see if this is running, and it's running correctly. Anyways, let's create a new file by using code, right? And let's name this my pod, or my volume, or what have you, right? YAML, okay? So this is our first demo for today's session. So I'm going to type, say, pod. And this is because I have the Kubernetes extension here in Visual Studio Code. And I want the name to be my app. The image say that I want Nginx, and the container port is 80, okay? Pretty easy stuff that we've seen in the past. And now I want to specify the volumes, right? So volumes is inside the spec field. Actually, if I go back to the terminal, I can run kubectl explain pod.spec.volumes. So I can obtain all the different fields and the entire documentation related to this field, right? This is, again, remember that kubectl explain is helpful in that matter because I think it has the most updated information about this Kubernetes version that you're using. Anyways, spec, then volumes. As you can see, I have IntelliSense, and the name will be my volume, something like that, okay? What else? In this case, I'm going to use empty there, right? And I'm going to use this syntax that I showed you in the slide. So this is the first part. I'm creating the volume, okay? And now I'm going to use volume mounts. So let's go back to Visual Studio Code. So volume mounts. And this is telling me, or this is asking me, right? Where in the world is going to be that mount path? Say, I don't know, var session 12. Is this session 12? I think so, right? Session 12 or 13? I guess this is session 12. And the name, it has to match, okay? It has to match. So actually, I didn't show you this. However, the volume mount name and the volume name, they have to match, right? So in other words, I'm going to go back here. The name should be my volume, right? My volume, right? Because this is the name of the volume that I want to map to this particular folder in the file system, okay? So pretty easy stuff. Let's go back to the terminal and let's kubectl. Let me clear the screen. Kubectl apply f my volume. Pretty easy stuff, right? I'm just applying the manifest file and kubectl get pods. The pod is being created right now. And on the second column, you can see that it's it only has one container. And I'm going to show you after this demo, the Sidecar demo, and we're going to create two containers in the same pod. So let's query again. And this particular container is running, right? So this mounted the var session 12 folder as the volume. Okay, so let's try this. Kubectl, what was the command? Exec and the name is my app, interactive, and is this bin shell? Yes. So as you can see here, I'm inside the etc OS release. I'm inside the container. This is the container instance, and I executed the shell. I'm inside the shell, so I can go and type all the different folders. And as you can see here, I have the var folder, and inside the var folder, I have the session 12 folder that was created when I deployed the pod, right? It was created because of the volume and those kind of things that I just explained. Of course, there is no file in here. It's just an empty folder. Of course, you can do something like, I don't know, touch hello world txt, and then you'll have the hello world.txt file. Let's do this. So you can see that this is just a regular file. Of course, it's a 0-byte file right now because it's empty, but actually it doesn't matter. I'm just showing you the relationship between the pod and the volume, right? So let's do the following. Let's exit this. And of course, if I execute again the shell, I will be able to show you again that the session 12 folder is right there and the file is there. And actually, if the container is restarted, the folder will be there, right? However, if the pod is destroyed, the folder will be destroyed as well, right? Because this is just the empty there way of doing things. This is the nature of this particular volume, okay? I'm going to talk about persistent volumes and persistent volume claims, which are a way of using durable storage. Anyways, so this is great. Let me show you another example, okay? This is the Sidecar design pattern that I mentioned in the previous session. Remember that the Sidecar is meant to help the main application. However, the Sidecar is not meant to be used directly, and it's not participating in your pod API. It's just running and helping and giving additional features to your main application, right? So I showed this in the previous session. This is just a small example about the Sidecar container. We have two containers, the main app and the Sidecar. So for instance, you can do this. You can say that your main application is Nginx. So you are receiving those requests and you're writing those requests data in the volume, and the Sidecar could read the data in the same volume. So it goes away and notificates to another platform or something. Actually, the concrete implementation of this, it doesn't matter. This is just a way of showing that the Sidecar container could use a volume for sharing data between containers. And I'm explaining this because volumes was the missing part of the previous session, right? You need volume somehow to use the Sidecar or the Ambassador design patterns for your multi-container pods. That's why I'm revisiting the Sidecar design pattern here. Anyways, say that I want to implement this or something similar, okay? Of course, you have your API v1 and kind pod, right? And metadata with the name. And inside the spec, you'll create the volumes field, right? In this case, the name is volume, my volume, right? And it's just using the empty there type of volume. And then inside the containers element, you're going to specify the first container, which in this case, in this particular case, is just using BusyBox, which is a very famous container image for running things, right? It's just a public container image that we can use for testing purposes or for doing things, executing things. In this case, as you can see here, this is running a while loop, and it's adding inside the date.txt file the current date and time. Okay? So this is just what this particular container is doing. Okay? So the important thing here is that the volume mount matches the volume. So this particular container is mounting the volume inside the data folder. Okay? So that's why I'm using data/data/date.txt. In other words, that date.txt file is being created in this data folder, which is the volume, right? And we're going to create a second container in the same pod, because this is the Sidecar example, right? And in this case, this particular Sidecar is based on the Nginx Alpine container image name, and it's mounting the volume inside the user share Nginx HTML, which happens to be the folder that Nginx uses for its source, for its content source, right? So, okay, let's do this. Let's do this particular container, multi-container demo, which is the Sidecar. And I'm going to copy the entire thing here because I don't want you to see me typing all the time. Anyways, let's go back here and let's do, I don't know, my Sidecar YAML. I want to create this pod, which is my Sidecar app, right? And I'm going to replace everything here in the spec field because, again, I'm specifying one container, which is the main application, right? And this second container, which is the Sidecar. The Sidecar is this Nginx thing, right? This Nginx web server. And both of them are using the same volume. The first one is mounting the path in the data folder, and the other one is mounting the volume in this particular path, right? And that's it. That's actually what we're going to do. Let's go back here to the terminal and let's execute kubectl apply f my Sidecar. Is that? Yeah, that's the name of this file. And it says that the my Sidecar app was created. Let's verify this, get pods. And as you can see here, in this particular case, this pod has two containers, right? And let's query the pods again, and both of them are running. I mean, both containers inside the my Sidecar app are running in this particular moment, okay? So, and that while loop is running, right? And it's creating the dates and it's appending the date inside that particular file. Let's try to do this. Kubectl port forward thing, is that the name of the command? Port forward, kubectl port forward my Sidecar app, right? And let's do this. Actually, I should have the command right here. Anyways, let's go back here. Is that 8,000? And then should I use this syntax? Yeah, I think so, right? Yeah, I was hesitating about the syntax. Anyways, this works. Actually, that's the correct syntax. So port forward is opening that port in my local machine, so I can query for localhost 8000, so I can query for the Nginx container, right? So is this returning something, or it's just executing like that? I think it's just executing that way. I mean, I'm not returning anything. So let's open up this other tab in here, say, I don't know, curl localhost, was it 8000? Yeah, 8000. And what was the name of the file? date.txt, right? So as you can see, all of those lines were created by the while loop, because if I go back here, I can show you this. So this is doing the while. This is just a bash syntax, okay? You don't have to be a bash expert to know that this is a while loop, and in each iteration, it's sending the date to the date.txt file. It's appending the data, and then it's sleeping for 5 seconds. Okay, that's what this particular loop is doing. And again, this is bash syntax. I could have created, I don't know, a ASP.NET Core Web API application with C# or any other programming language with another framework that does the same thing, right? It's just sending data in a while loop. Anyways, if I execute this again, you can see that this is sending the data each 5 seconds. So 4, 9, and then 19, and so on and so on, right? So again, let's go back here. I created this, right? I have two containers inside the same pod. This is the Sidecar container design pattern, which is a way of running two containers, and one of them is helping the main application. In this particular case, the main application is, maybe those names are intertwined, because for me, the main application could be the Nginx Alpine, right? The main application is the web server. It's not the other one, or it could be the other one, I guess. Anyways, the thing here is that the main application in this particular code is sending the date to that file, and the other one, which is the Sidecar, is just helping, query that particular file, date.txt. So pretty easy stuff in this demo, which is similar to the diagram that I showed you here. Actually, I think this is a little bit different because the Sidecar is not reading, right? Well, yes, I think it's reading. What's different is that I don't have a request. The while loop is just executing by itself. Anyways, this is a different approach. The thing here is that both containers are working together to give me this complete application. Okay, cool. So now let's talk about persistent volumes. Volumes, such as the emptied var, those are great. However, as I mentioned before, those are created and destroyed with the pod. In other words, the volumes, such as empty var, those are based on the same life cycle as the pod. That's what I mean with this, okay? However, most of the time, pods will be destroyed, right, in your applications. Or maybe you want to move one particular pod to another node. I mean, not you, but the scheduler, the kube scheduler could move your pod to another node, or could destroy your pod, or there's a lot of things happening with your pods, right? So that's why sometimes, or maybe most of the time, you'll need a durable persistence mechanism, right? And this is why we use persistent volumes and persistent volume claims that I'm going to talk about right now. So persistent volumes, they provide long-lived, durable storage for Kubernetes applications. Think about persistent volumes as a way of representing physical storage devices and resources such as disks, NAS, cloud storage, right? With cloud storage, I mean, I don't know, for example, Azure disks, right? Or AWS, the name of the AWS disk. So each cloud, they have their own storage options that you can use for your Kubernetes applications, okay? What's interesting about persistent volumes is that they are independent of the pod lifecycle. So if you use a persistent volume, this means that you can destroy your pods, right? And the data will be there because the lifecycle is independent of the pod ones, okay? So it doesn't matter if your pod is was created or destroyed. It doesn't matter. Your data will be there, right? So persistent volumes is useful for those kind of storage options, such as, I don't know, maybe databases or databases files and those kind of things that we need for database technologies. You can use this, right? Because the data will be there. This is durable. So there are two ways of provisioning persistent volumes, okay? Statically or dynamically. The first option, most of the time, a Kubernetes administrator is going to create those statically created persistent volumes. Those are persistent volume objects that you can create by using a manifest file. And I think that's the role of a Kubernetes administrator, right? Anyways, if an administrator creates a persistent volume, then that particular persistent volume will be available for persistent volume claims that I'm going to show you in a little bit, okay? So the steps for creating persistent volumes, I mean, statically creating persistent volumes is first, you create the storage device. Of course, you need to have the storage device, right? Say a disk or a cloud storage disk, or I don't know. And then you're gonna reference that by creating the persistent volume object by using a manifest. And then you're going to reference that particular storage device, right, or resource in your manifest file. So that's statically creating a persistent volume. And the other way is dynamically creating those persistent volumes, because if you create and apply a persistent volume claim, those persistent volumes will be created for you. Okay, so there's a way of automatically creating the persistent volume objects for you. So, and actually, I guess I'm going to show you the dynamic one, because statically, yes, I think I have the code. Yeah, I have the code for statically creating the persistent volumes. As you can see here, is similar to other objects in Kubernetes, such as, I don't know, the pod or deployment or whatnot. So you have the API version. You can see that this is V1. The kind is persistent volume, metadata with the name, right? And then the spec. Inside the spec, you specify all the different features that your persistent volume will have. In this case, it's specifying 10 gigs and read write once. In other words, one single node is able to read and write in this persistent volume. There are other options for access modes. That's in the Kubernetes documentation. And this is using this local path for specifying where in the world is this persistent volume, okay? So pretty easy stuff. Actually, the administrator creates those manifest files. They apply the files to create the persistent volumes, so you can use them in your persistent volume claims. So what in the world is a persistent volume claim? You know what? I think this is a complete example. I believe that I created this just for copying and pasting. Let's do this. I don't know if this is going to work or something else is missing, because sometimes I cut out a lot of text because of the slide size, okay, and the resolution that I'm using. Anyways, let's try to do this. My persistent volume, okay. Again, system volume is the kind. This is specifying, you know what, 10 gigs, read write once, and the local path will be this path. And if I go back here to the terminal, let's run kubectl apply my PB. Is that the name? Yes. My local PB is invalid. Required by local volume requires a node affinity. Yeah, it looks like something's missing, such as node affinity. I think that I got out. Let's try to do the following local. I guess if I use host path, I don't know, what was the previous one? Host path. I don't know if this is going to work with host path instead of path, instead of local. So let's try again. So yes, in this other case, I changed the values, and now the persistent volume is created. Not that I'm going to use this persistent volume at all, right? I just wanted to show you how you can create those persistent volumes. Again, this is for Kubernetes administrators, because as you saw in my first attempt, you can specify some other things related to the storage attributes and storage traits that you're going to expose to your applications, okay? Anyways, now that the persistent volume was created, you can query for those by using persistent volume, right? This is the name, or you can use the alias, which is that PB? Yeah, PB is the alias of a persistent volume, okay? So as you can see, I created this, my local PB, and the capacity is 10 gigs, and access modes. In this case, I'm using this one that is allowing me to read and write once. This means that I'm going to read and write from the same node. And reclaim policy, it's the policy of specifying if you want to retain or delete the volume when the claim is disconnected or is unbound, okay? Anyways, as you can see, this is very easy stuff. Just, creating the persistent volumes is easy. Anyways, it's not something that I'm going to use right now when I use the persistent volume claims, because I want to create the persistent volume automatically. Anyways, persistent volume claims, those are claims that you can use in your pods for specifying, hey, I want this particular storage resource in this pod, okay? So this claim is just a way of asking for storage resources, okay? That's the claim. That's the easiest description for a claim, is asking. So those persistent volume claims or PVCs, those are requests for storage, right? So at the end of the day, you could have dozens or a number of persistent volumes, some of them for disks, some others for NAS, some others for cloud storage, right? And the claim is asking, hey, you know what? I would ask you for this particular storage resource. So when you ask for this, when the claim is created, the control plane will look for an available PV or persistent volume that meets the requirements that you're specifying in the PVC. Okay, so it's asking, it's just a way of ensuring that you have this minimum request, this minimum resources in your request. So, and it uses a storage class. This is an advanced topic for administrators. The storage classes, they define a class for storage devices and resources. And those are usually defined by an administrator as well. So at the end of the day, if you want to pass the CKA exam, which is the Certified Kubernetes Administrator exam, then this is something that you should know, and you should know how to create. Otherwise, for us developers, I guess this is not something that we use a lot, okay? And on the other hand, because of the fact that I'm using Minikube, when you use Minikube for deploying your Kubernetes clusters, Minikube creates automatically the standard storage class. Actually, let me show you this. kubectl get storage class, right? So as you can see here, I have the standard storage class and some of its properties that were defined by Minikube when I deployed the cluster. And actually, you can use this or SC, which is storage class, okay? Anyways, storage classes are an advanced topic for other session. Anyways, let's go back here to the persistent volume claims topic. As you can see here on the screen, I'm using API version v1, right? The kind is persistent volume claim, okay? The name is important because that's the name that you're going to use for your pods, right? For referencing the PVC in your pod. And inside the spec, we have the resources and the resources field, and then requests. And then you specify all the different requests that you need, all the different minimum values that you want to get from the persistent volumes. In this particular case, it's asking for 122 megabytes and for a read write once kind of persistent volume, okay? Remember, this is just for asking. So if you create this, actually, you know what? Let's do this. However, I'm going to use I can copy this. However, let me show you this template that I have in my Visual Studio Code. Say that I want to create my pvc.yaml, so I can type, you can see persistent volume, right? Or persistent volume claim. I have those two templates inside my Visual Studio Code because of the extension that I installed. This is the same extension that I've been using for creating pods and deployments and services and those kind of things, okay? So you have the persistent volume and also the persistent volume claim template. Anyways, here you specify the metadata, my PVC, that's fine. Storage, so let's ask for 122 And volume mode, actually, I think the default is file system. Actually, you can get rid of this so it reads better, cleaner, right? And you're asking for this read write once persistent volume, okay? So great, let's go back to the terminal and execute kubectl apply f my pvc.yaml, and we can query for those persistent volume claims, get persistent volume claims or claim, right? Or PVC, actually, that's better. Let me clear the screen up. So as you can see that persistent volume claim was created successfully. I know that because the status is bound and it's telling me some features about this particular PVC that I just created, okay? And it's using the storage class that Minikube created, which is the standard one. Anyways, I have the PVC now. However, you need to map it. You need to use it in your pods, okay? It's not that this is gonna work somehow. You need to use it from your pods. So let's go back to the presentation, because this is actually what I'm going to do now. As you can see, this is just a regular pod, right? API version v1, kind pod, metadata, spec with the containers, right? And here, this is pretty interesting because as you can see here, inside the volumes field, I have the persistent volume claim field. So you use this and you specify the name of the claim, of the name of the PVC that you want to use in this particular pod. And then you use the volume mount as usual, right? So this is mounting the PVC, which is bound to a particular PV inside this data path. Make sense? So let's do this. I'm going to copy this entire code. Let's go back here and my pod with PVC or something .yaml, right? So I guess if there's a lot of things that I need to write, such as volumes, blah, blah, blah. Let me just copy this to expedite this process, okay? So volumes, I explained this, and at the beginning of this session, I'm creating this my volume, right? And now I'm using the persistent volume claim, which is my PVC. Remember that? My PVC was created. This is the name of the persistent volume claim. That's why I'm using this as a reference inside the volumes field. And the volume mounts, actually, it's the same as before. I'm just mounting the volume in a particular path inside the file system of this container, which is data, okay? So at the end of the day, if I write data inside the data folder, then the data will be persistent, that it will be durable, right? Let's try this. Let's try and see if everything is running correctly. Kubectl, what was the name? Kubectl apply f my pod PVC, blah, blah, blah. Looks like something is wrong. Pod updates. Okay, looks like I already have a pod name like that. Kubectl get pods. Yeah, my app. So kubectl delete pods, my app. So yes, I deleted successfully that pod, and let's apply this file again. So if I execute kubectl get pods, you can see that now the pod is running again. However, that particular pod is using the PVC, which is bound to a particular persistent volume. Okay. So actually, if let's do this, kubectl exec my app interactive bin shell. So you can see that I have the data folder, right? So if I go to data, of course, there's nothing there. Let's touch hello world txt. Again, oh, I don't know what's going on here. Right, I have the file. It's empty. However, it doesn't matter. Okay, so let's do this. I have the pods. Let's delete that particular pod and let's create that pod again. Okay, so I destroyed the pod and then I'm going to create the pod again by running, apply f blah blah blah. So I should have my app pod right now. And if I execute this command again, I should see data and also the hello world file, because of the fact that this is a durable storage, even though I destroy the pod, right? Can you see this difference? So that's why we can use persistent volumes and persistent volume claims when you want to create stateful applications in Kubernetes. So this is great, and I think that's what I had for today. Yeah, the diagram that I wanted to show you is actually the demo that I've done. Okay, we have the pod with a volume, right? The volume is referencing the PVC, which is the persistent volume claim. The claim is asking for and it's binding to this particular PB that I have, right? And the PB is a way of communicating to a persistent storage mechanism such as disks or cloud storage options or NAS or whatnot. Okay, so actually, this is the entire relationship between pods, volumes, PVCs, PBs, and finally, the persistent storage that you're using, in this case, Minikube Creative, the standard one. However, I could be using an Azure disk or AWS disk or whatnot, okay? So, okay, this is what I had for today. And the next session will be about daemon sets and jobs. And thank you, friends, for your time. And see you on the flip side, okay?